In this video, we are going to learn about how to create a schematic symbol and PCB footprint for a microcontroller IC which is having a part number ATmega328P-PU, which is a very common microcontroller IC used in Arduino development board. And most of the Arduino DIY projects are built on this particular microcontroller. Hi everyone, I am Vaibhav Sugandhi, co-creator at Linked Frequency. As always, this video is divided into 4 important parts. First one is understanding the datasheet and understanding how this through-hole technology ICs are designed in ATmega328P category. Second step is to creating a schematic symbol using EasyEDA tool. Third step is all about creating a PCB footprint using the IPC standards and a Cartesian geometry. Last but not the least, the fourth step is for combining a schematic symbol and PCB footprint to create a component library. So let's get started. This is the datasheet of Atmel 8-bit AVR microcontrollers, which is having a series of 4, 8, 16 and 32. That 4, 8, 16 and 32 indicates the amount of bytes of in-system flash memory inside that microcontroller. This datasheet is having a tons of information which are essential for a developer and designer. However, in this particular tutorial, we are not going to dive deep into those details, but focus on something that is important to us. First thing which is important to us is this description, which is essential to understand before starting with any project. But right now, we are very sure this particular datasheet is having a microcontroller part number that we want. How do we know that? We will get to know that in first page or in second page, wherever there is an overview is given. In this, we can see that ATmega328P is the series of part number that I am looking for designing today. So that's why this datasheet is suitable for that. Then if we go to the pin configuration, we can see that the PDIP-IC package is available. Because this tutorial is focusing on through-hole technology, and through-hole is having a PDIP footprint design. And if we have a schematic symbol representation of that particular IC, then only we should consider this datasheet for analysis. While designing a schematic symbol, we will be having a 2 options. One is going ahead with the same design as given in the datasheet as per pin number, like pin number 1, 2, 3, 4, and giving all the features that is given on the schematic symbolical representation in datasheet. Or what we can do is we can categorize them based on the port number, based on the power category, or based on the electrical property of those particular pins and make them aesthetically look good. Choice is yours, but I prefer to go with the second option. And the next important part, what we have to look into this particular datasheet is all about the overview of how this entire IC looks like in a block diagram, so that we can understand how to categorize the pins in schematic symbol. But that's not so important to us at this point of time, so I'll not go dive deep into that actually. The next important thing is when we go to the packages, we have 2 options. One is SMD version, which is all about ATmega328P-PU, which is SMD package of designing a footprint. But what we are focusing is ATmega328P-PU, which indicates a PDIP-28 pin IC design in this particular category. With these information, we are good to go for schematic symbol design activity. So let's get started with that. Now I'm on EasyEDA tool and I'll go to the file and create a new symbol library. Here, first thing is we have to create a very pin configuration for all the pins that we are provided in this IC, which is starting from 1 number to 28. We'll place all those ICs as per the schematical representation in datasheet, and we'll assign the pin number and pin name and category to that particular pins first, and then we will arrange them in a way that we want it. It is going to be a little time consuming and very focused work, so make sure that you do it carefully, because if you miss any particular pin number and a pin name association and do it in a little bit here and there, then entire schematic library is going to be waste of time. So that's why make sure that you spend a very good focused time on developing such kind of a complex schematic symbols when you're designing a library activity. So let's get started with that. Now you can see that all the pins are arranged properly and entire IC is designed as per the electrical standards. First thing is I have categorized VCC pins and A reference pin as one category because they are all power related. And then we have two grounds in the entire IC, so which I have categorized and kept them at the bottom side here. And one port, which is the D port of the entire microcontroller IC, which is having a PD0 to PD7, all are categorized in one category and kept them one side. Other two ports are managed on the other side of the IC, keeping it balanced between left side and right side so that it looks like a dual inline package IC. As well as one thing I have noticed here, we do not have PC7. Why? Because even I don't know, I forgot it a long back. I have studied about it, but I forgot it. But right now, as per the data sheet, which I have referred and tried to find it out, we do not have PC7. PC6 is there, which is treated as a reset pin. PC7 is not available for this particular DIP IC. Even for SMD also, I couldn't find it. But anyway, we can refer all the 28 pins are considered in our PDIP design. That's enough. And then I have given the PC0 as well as the alternative multiplexed functionality of that particular pin in the same name. Why? Because when you are designing, you wish to know what is the alternate functionality of that particular pin when you are designing a specific application. So that's why it is always better to give. For example, we have a PC4 and PC5. PC4 is a I2C SDA pin and PC5 is a I2C SCL pin. Every time I cannot go back to the data sheet and find out where is the I2C pins are dedicated, which is very tedious and time consuming. Rather, I would like to provide that information in the same pin name, which will make the IC looks a little bigger, but that's fine actually. That is the part of the game actually. So that's why I have given. But one thing which I have identified is a good one is we can reduce the size of these font so that it looks a little bit compact and a little bit easy for anyone to read at the time of designing. And I have changed the size of these fonts to 5.5 points. Earlier it is going to be a 7 points and I have changed it to 5.5 points. This is how the entire schematic symbol for ATmega328P-PU has to be designed. And one more important thing, I have referred the information of manufacturer data and the supplier information and supplier data from the website called Moser India. This is one of the genuine source from where we can get the component. Of course, this video is not sponsored by them, but I use them all the time whenever I'm designing. So that's why I recommend you to get the detail about supplier part number, supplier and manufacturer part number and manufacturer detail from these kind of websites only. So once we are done with all these things, we are done with creating a schematic symbol for ATmega328P. Now it is time to go for creating a PCB footprint for this particular IC. As we know, PCB footprint is a package of PDIP, which is plastic dual inline package with a 28 pin, which is going to be a little complicated than the previous tutorial where we have designed for 16 pin PDIP, but geometry and the Cartesian geometry and the calculations are going to be pretty straightforward as we did for 16 pin. So let's get started with that process. Now you can see that we have completed creating a PDIP-28 pin IC footprint design. As I said, the Cartesian geometry is going to be straightforward if you have understood how to design a PDIP-8 and PDIP-16 package, because it's all about fundamentals. It's all about using a calculator to add 1.27 mm to 2.54 mm again and again until you reach all the 7 pins on the top side, and it is going to be same replica on the negative y-axis, and it's going to be pretty straightforward. And if you are still interested to cross-verify the dimensions, of course you can go through the datasheet and use these common dimensions and verify them as per your requirement. But right now I have completed creating a PDIP-28 package IC footprint design. Now it is time for going for the combining both of them and creating a component library. For combining and creating a component library, I'll come back to the schematic symbol that I have designed, and in that I'll click on the footprint option. Here I'll search for PDIP_28, which I have just now designed. And here you can see that I have created a lot of PDIP ICs in last probably 4 to 5 years when I started using this EasyEDA. In that, PDIP-28 is one which I have recently designed, and there I'm going to click on it and make sure that all the pins are connected to the GPIO pins or the power pin that we have designed right now. Because if any pin is missing, then it will show a red color indication here. That is a very important part to cross-verify when you are designing a complex ICs which are having more than 16 pins or more than 28 pins in such cases where you are designing a microcontroller. So just make sure that all the pins are connected properly and then click on update footprint. On that, we are done with creating a component library for ATmega328P-PU. How does it look like when you are starting designing with a schematic? I'll just create a dummy schematic here, and I'll go to the library and I'll search for ATmega328P-PU just to make sure that we get the right part. Yes, I'm in my workspace and you can see that our library component is completely created. I'll just place on schematic symbol. This is how it looks. Looks very beautiful to me and very aesthetic when it comes to designing schematics. And what about the footprint? Yes, it is also assigned with the PDIP-28 which I have just now created. And notice all the Moser detail, whatever you have selected while creating a schematic symbol, are also reflecting when you are designing a schematic with respect to this particular library component. I believe you have enjoyed the entire process of creating a schematic symbol and PCB footprint for ATmega328P. If you have any questions or concerns or suggestions, feel free to comment down below in this video. See you again in the next video. Until then, tune yourself to make a difference.